check to make sure if we have one in the back in case you guys want one here too. But so we've got one in the back. So I'll be using that one.
Okay.
You can use this one as you wish. Thanks.
Good morning, everyone. So excited to have you here. Has everybody been having a good time at the summit so far? It's been a bit mind-blowing, so I'm excited about that, and I'm thinking you're going to have another mind-blowing presentation today. Okay, before we get started, I want to encourage you, if you haven't done so already, to please download the Crowd Compass Attendee Hub app in the App Store. Once in the app, search Transportation Summit and download the event. The app will provide you with an up-to-the-minute agenda, as well as to allow you to network with other attendees and participate in an interactive game. Now, I've heard that there's a TV involved, so you might want to get on that game, just saying. Under the schedule, if you go down to the 3D event, which is this one, click on that and scroll to the bottom, and there'll be a short survey. I think it's only 2 questions. You can also participate through social media by using the hashtag NC Transportation Summit. Now, welcome to our breakout session where we will be exploring groundbreaking new technologies that have the potential to revolutionize the way we design, build, and install infrastructure in the future. My name is Lisa Mathis, and I'm honored to serve as a member for the North Carolina Department of Transportation Board. As many of you are well aware, the installation of infrastructure is extremely labor-intensive, and it's a time-consuming process. North Carolina's growing population and subsequent need for an ever-growing transportation system requires that new roads and tracks are laid down nearly every day. How do we continue to provide for North Carolina's growing need for new, adaptable, and resilient transportation systems? To offer their perspectives on a potential solution, we have Megan Krieger and Brandy Diggs-McGee from the U.S. Army Engineer Research and Developmental Center. Please help me in welcoming Megan and Brandy to the stage.
So I'm Megan Krieger. I'm the program manager at the Engineer Research and Development Center, Construction Engineering Research Lab. Our lab is essentially the research arm of the Army Corps of Engineers. So anything that's kind of the innovative, whether it technologies, whether it's 3D printing, all the way down to different paint technologies and energy, is what our facility does. And with me today is Brandy Diggs.
Hi, I'm Brandy Diggs-McGee. I'm a mechanical engineer. I specialize in energy efficiency, thermal analysis. I'm also the site coordinator for our 3D printing efforts there at the lab. I work closely along with Megan.
So before we get started today, I want to ask a couple questions of the audience. Everyone loves these kind of questions, but how many people have heard about 3D printing in some capacity before coming here? Which is pretty much everyone, right? Now, one of the things that is kind of misleading in 3D printing is people seem to think it's a future technology. So the next question I want to ask is, how many of you use 3D printing at your company or business in some capacity? Raise your hands. So there's a few of you. So what we're here to talk about today is we're going to cover a little bit outside of our realm, which is regular 3D printing. We're also going to cover large-scale printing and then infrastructure printing. And so the very first thing I want to talk about is 3D printing in general. So 3D printing is full of hype. Like, hype is everywhere. Everyone says 3D printing is going to be a revolutionary technology that's going to transform the entire world. Everyone's going to have a 3D printer in their house and be printing all the goods that they need in order to survive. Now, there's some truth to that, right? But a lot of technologies are prone to these extreme levels of hype. And so what we want to do here today is clear away the hype and the buzz and talk about what is actually being done and where is it going from here. So 3D printing is across the board in pretty much every industry, whether it's transportation or the medical industry. People are printing clothes, for fashion, all the way to printing full-scale cars and buildings and bridges. So what is 3D printing? 3D printing is essentially additive manufacturing. People like to argue about whether to call it 3D printing or additive manufacturing. Additive manufacturing is literally the manufacturing environment version of 3D printing. So I'm just going, for simplicity, going to call it 3D printing throughout this presentation. Understand sometimes I'm talking about additive manufacturing. It is using a computer, like a CAD software, to 3D model a design and then control the building of that object with that design. So you take a CAD model, you break it up into different slices, and then you are able to path plan and create an entire object from the bottom up or from the side over, however you want to do it, depending on what kind of 3D printer you have. This is in contrast to subtractive manufacturing, which everybody who's in manufacturing uses subtractive. It's grinding away material to make your part, which has a lot of waste associated and limitations. Now, 3D printing versus subtractive manufacturing, it's not an either-or scenario. And that's kind of the thing that I want you to get from this presentation is additive manufacturing is a method. It's not an entire all-encompassing thing. It's something that can be used with conventional manufacturing or conventional construction in order to get what you need done based on the abilities of 3D printing. So why would you do 3D printing? Well, because it can be faster. So if you need a part right now made out of metal, plastic, whatever material you need, it is likely faster to print a one-off part than it is to go through and do all of the conventional manufacturing process to build molds, jigs, design it, go through, drill out the holes. Any kind of complex part requires a lot of time in order to make. And so with this, you can get single-step manufacturing. So instead of building a part out of 20 parts, you can now make an incredibly complex object that is one part. And these kind of objects fit into the environment where they need to be. They can also be less expensive. It's much less expensive to print one than it is to run an entire line to print hundreds if you only need one. And then you have hundreds of parts sitting on a shelf that are not getting used. With this too, you can get incredibly complex parts. So because you're not using any molds or you're drilling out holes, you can have intricate interior geometries and exterior geometries all in one. So you can have parts that can't be made conventionally, which we'll get into a little bit later. You can also have customization. So there are companies out there that say design hearing aids that are custom fit for your ear based on just taking pictures as you go around. That is one version of customization. So things that need to be customized can, because everybody's parts can be printed on one print bed that's different. So we can print 100 different things on one print bed with the same material and make a custom version for everybody if that's the desire. They're also easy to access. So you can have distributed manufacturing instead of centralized manufacturing. So instead of thinking about it being in everyone's home, picture several facilities set up around each town in order to do these kinds of operation. Now, another benefit of this is sustainability. So we can now, instead of having a lot of waste materials when we're manufacturing parts or buildings, we only use the material that we need in order to actually build the part. So you can have a lot of cost savings. You can also use it to make lighter weight parts and have more energy efficient parts. So with this, we heard a lot of presentation this morning about autonomy. Each of those companies, whether it's Daimler, UPS, or we can talk about Ford, GM, any kind of transportation company is using 3D printing. I want everyone to be aware of that, is that cars, planes, all transportation services already have 3D printed parts in them. So when people talk about revolutionizing an industry, understand that if you're not already looking at 3D printing with your business, you might already be too late because people are integrating them for their benefits.
So some of the reductions and the improvements that are in the construction and manufacturing industries, in addition for or using additive construction, is the reduction in cost, the hard labor that's put on the employee. Also with the tools, there are specific tools that you won't have to use now that you're using additive construction. I call it additive construction because that's what I'm used to. I am speaking about 3D printing, I apologize. You don't have to have the labor intensity with your formworks because now you can actually print what you would normally need for a form, all while improving your building capabilities in ways that you probably couldn't have thought of before. It's a new way of exploring ways of doing different things, different and innovative things that your company could advance in, all while reducing costs. And who doesn't want to reduce costs and build a budget for yourself?
So there's a little bit of a difference between small scale 3D printing and large scale. So the thing that most people are aware of, when I said, have you heard of 3D printing? Probably what most of you have heard of is small scale 3D printing, which is 3D printers in your own home, metal 3D printers to print parts. Anything that's really less than a meter cubed is what I'm talking about with small scale. Now, less common is large scale or large format 3D printing, which is greater than or equal to a meter cubed. So you're talking about, say, a 3D printed propeller that's on a boat. That's a WAM-peller. It's WAAM. WAM-peller that was designed to be a more energy efficient propeller to show that you can use this in kind of boat kind of technology. Or 3D printing cars, which we'll get into that a little bit later, all the way up to construction scale 3D printing, which is much, much greater than a meter cubed. And so that is an extremely rare form of 3D printing. Like the amount of printers in this country that is much, much greater than a meter cubed can probably be counted on your hands in this entire country. So I'm going to hand this one over to Brandy.
Sure. So I have a question for everyone here. Would you rather drive this car on the left? Sure, it gets you from point A to point B, but eventually it's going to have to change. And the way that it's going to change is that you're going to have to start driving the car on the right. This car has been 3D printed. The exterior of the car has been 3D printed. It has a skin that's waterproof. It's also lightweight. So you could stay with the car on the left, your left, my right, or you could drive the car on the right. The thing with this question is that it doesn't matter if you want to continue with the car on your left or if you want to drive the car on your right. It doesn't matter. 3D printing is pushing everyone into the new and innovative technology.
So as we get into these technologies, I want everyone to understand that 3D printing is all around us. Now, if you flew in on a Boeing 737, you have a 50% chance that you flew on a plane that has a 3D printed part, because there is a 3D printed fuel nozzle that you can see in the bottom left-hand corner there that is a world famous 3D printed part because it reduced 20 parts down to one single part, increased the energy efficiency of it, and also decrease the cost and increase the speed of the manufacturing time. So in this part, it's a little deceiving. They show a picture of the whole thing. The whole thing isn't 3D printed. It's really that circle on the bottom left. There's a really intricate part in there that's 3D printed. And all the different companies in aviation are really looking at 3D printing, and they're trying to integrate it into the airplanes, whether it's the Air Force or GE. They're really trying to integrate this and go through and get validation of these parts. Now, most of the 3D printed parts that you see in industry are the ones that are not critical. So it's ones that if they fail, no one's going to die, because the worst thing that could happen is something fails that was 3D printed or in general, and somebody dies. Whether that's a building, a plane, a car, we don't want to be the cause of any kind of catastrophes. So for Boeing, what they've been doing is trying to incorporate 3D printing across the board into their planes, and they actually estimate that they can save between $2 million and $3 million for every single plane that they make. That's a massive savings by just incorporating 3D printing. And some of these places where 3D printing is being incorporated is things like these partitions up on the top there. They're being 3D printed out of metal to make it kind of biotic and to make it lighter weight, stronger, more cost effective. Basically, people across the board do these things for very similar reasons. Now, there's also NASA, who 3D prints parts. They also 3D print structures. We were part of a competition called the 3D Printed Habitat Challenge, where different companies were involved in coming and competing to see if they could print space habitats. And the reason for that is because, you know, equipment and astronauts are going to need places to land and live if we are to get more serious about space travel. That was the wrong way. Also trains. So typically people think of trains and they think of outdated technology. Well, guess what? Any kind of outdated technology is perfect for 3D printing, because 3D printing is great for creating one-offs, which means if you have trains that need parts that are no longer in existence, or tractors that are out there that they no longer make parts for, you can 3D print these parts easily for a lot less money than what you can make them conventionally. Now, trains are kind of across the board trying to get more efficient, whether that's the station that they're at by 3D printing handrails so that the visually impaired can actually figure out where they are by reading on the rail which stop they're at, or whether it's the headrest, which is that picture in the middle that different companies are printing across the board, or printing armrests for these trains, because we can make them lighter weight, we can make them customized to fit whichever kind of chairs or environment are in each of these different vehicles. And by making these more lightweight, we save a lot of fuel, which then saves energy and money. And so across the board, everyone's trying to incorporate 3D printing, not for the sake of 3D printing. Like, a lot of people like to 3D print stuff for 3D printing it, to be the first one who's ever 3D printed something. But really where 3D printing takes the cake is when it actually makes the entire process better. And so one of these areas that 3D printing is not really talked about a lot is with Ollie and Local Motors. So Local Motors is a company that started out 3D printing cars. Most people have heard about the first 3D printed car, which I don't have the picture up there, but the nice 3D printed car they made was the Shelby Cobra. So that picture up on the top left is a picture of the 3D printed Shelby Cobra that they finished and made it look like a normal Shelby Cobra. From there, they moved on to creating, I think they call it like micro-transit. So the Ollie system is an autonomous shuttle system that can operate on closed loops or open loop areas. And the thing that kind of gets passed by a little bit, because it's not the most important thing, is that Ollie is 3D printed. 80% of Ollie's parts, that bus off on the top there, is 3D printed. And they can produce this shuttle in about 12 hours, which means anytime someone has an order for these type of vehicles, they can mass produce these because they don't take very long to make. And a few other examples of automobiles that have been made are Oak Ridge National Labs did the Amy project, which is a picture right underneath the Shelby Cobra, where they made an energy efficient home, which they 3D printed, and they printed the car, and they both integrate and share the same electric system. And so if the house needs more power, it can pull it from the car. If the car needs power, it can pull it from the house. And across the board, people have been trying to see where 3D printing makes sense, whether it's campers, which is in the bottom there, that was someone who just made that at home, whether it's motorcycles, which were that one off to the right is made by Honda, or off to the left, University of Maine was working with the Army in order to create a mobile transportation unit so that we can have mobile housing.
What's not being 3D printed in like those ollies? Like you said 80% is, what is not being 3D printed?
I think it's mostly the battery system, the electrical portion of the Ollie.
Tires and the glass.
The tires as well, and the glass are not 3D printed. But everything else is my understanding. I believe even the rims are probably 3D printed, and if they aren't, they probably will be soon. There's also in boat technology, we've got a wet submarine that was produced for the Marines, which was completely 3D printed. That's off to the left there. The whole purpose of that is so that Marines can have a way to do covert maneuvers. It's not intended to be dry on the inside. It's called a wet submarine because it's wet on the inside, so they can transport goods with that. Also, there was a 3D printed boat hull about 2 years ago created by Thermwood, who is a 3D printing company that does large-scale polymer 3D printing. And they worked with University of Maine to create the largest 3D printed object, or the first 3D printed boat in the US, which is off on the right there. And that was just a couple months ago. Now, like I've mentioned, there's a lot of hype in this industry. People will tell you it's going to revolutionize the world. Well, it's going to revolutionize various aspects of the world. And it might start sneaking in where you haven't seen it yet. Now, just like the autonomous discussion this morning about how autonomy is already starting to sneak into transportation, 3D printing has done that as well. Now, when we talk about this as a group, we work with 3D printing for infrastructure. So we're talking about bridges, buildings, etc. So when we talk about hype for our industry, we're talking about people saying we can 3D print a building in 24 hours for $10,000, and it only took 2 people to build this building. I'm going to tell you that's not true. I'm going to tell you that anytime someone says it took me X amount of time to 3D print something, I want you to ask them how long did it actually take? Because people have a tendency to talk about print time, which is kind of like the Windows taskbar, where it will tell you it's going to take 5 minutes, and then you've sat there for 3 hours, and it still hasn't worked. And it used to be, way worse than that. But the point is, if you want a building in actually 24 hours, going by these kinds of terms by saying you can print a building in 24 hours is misleading. And since we work for the Army, when we talk about printing buildings, they don't care how many hours you were sitting at a printer. They want to know, when can I move into this building? From the time that I go to set it up, when can I move in? And so a lot of the news that's out there, like this little cartoon illustrates, you forgot to turn on the 3D print, turn off the 3D printer, come back the next day, there's a whole building there, a whole skyscraper. It's not quite like that. And so when we talk about hype, we want to get into industry and where is this technology. So on this plot, which is done by Gartner, it's called the Gartner's hype curve. Now this is the Gartner's hype curve for 3D printing. What Gartner does is they evaluate technologies to see how far off are they, where they are on this curve, and how long is it going to take to adopt. So there's different things like mainstream adoption on this chart, as well as expectations. So this is expectations versus time. Now, on this plot, like I said, regular 3D printing, we've got everything from 3D printing nanoscale, so very, very tiny, all the way to 3D printing for hearing devices, which is all the way on the right. Now, how to read this plot, I'm going to walk you through it because it can be confusing. Off to the left, we have the innovation trigger, right? So that's when someone says, I have this great idea that's going to change everything, okay? And then as we move across time, we go into the peak of inflated expectations. So this is where we all talk about how great everything is, about how everything's going to change the future. Immediately after that is the trough of disillusionment. The trough of disillusionment is where technologies go to die. There have been a lot of great technologies in the past that have been far superior to what we use today that were not adopted because of the trough of disillusionment. Now, what can happen in an industry is people can talk about how great something is to the point where nothing is true anymore, or people don't believe it anymore, and they fall into this trough. After that, you get the slope of enlightenment where people go, hey, I actually do have some really great applications for this technology. And then you get the plateau of productivity where things have actually made it to mainstream and are used day to day. That's where the 3D printing of hearing devices is. Now, construction 3D printing isn't exactly on this chart, so I'm just going to throw us in with macro 3D printing because I'd say we're pretty macro. Off on this chart, you can see the lower arrow is where they put macro 3D printing back in 2017. Still in the innovation stage, still climbing up towards the peak of inflated expectations. In 2019, now 2020, I would say that we are probably slightly past that peak. At least I sure hope so. Because when we talk about this, we want to talk about real applications, not just the first in the world, the greatest, the largest. We want to talk about where the innovation is actually happening. And so how do we get across the trough of disillusionment? And where that comes in is collaboration. Because in collaboration, you can start to understand where applications are, you can improve technologies to the point where they can be adopted easily. And that's what we like to work in. And so we have a number of collaborators all the way from Caterpillar to Oak Ridge National Laboratories. We've worked with Skidmore, Owings and Merrill, structural firm out of Chicago, as well as the University of Illinois. And so we try to broaden our spectrum, work with everyone from academia to industry to other government labs in order to make sure that the technology is not just looking for a problem, that it's solving a problem, that it's a solution. And so what is additive construction, right? I told you what 3D printing is. So additive construction is a construction process that a machine uses a 3D CAD model to produce a large-scale component by depositing material in successive layers. We do concrete additive construction, so it's the same thing, but with concrete. And so with that, you can kind of picture it like when you put frosting on a cake, or when you're going to get ice cream from an ice cream machine. You kind of build from the bottom up, extruding layer by layer until you've completed a whole object, whether that's an ice cream cone or a frosted cake. And so we'll get into some kind of terminology here, just for the sake of simplicity. We don't operate in a bubble. We operate with the construction industry. And so we want to keep our terminology reminiscent of the construction industry. And we have several members of our team that are actively involved in the American Concrete Institute as well as ASCE in order to make sure that as we develop this technology, we are in tune with what industry needs. And for this, we talk about different methods of construction. So in regular construction, you have precast concrete specimens that you cast in a factory and you bring to the site and then you assemble it. For 3D printing, you can do something similar, which we call pre-printing objects. So you can print objects off-site, move them to site, and then put them together either with conventional components alongside the 3D printed components or an entire 3D printed structure. The next one is cast-in-place concrete. So that's when you're making your foundation, you put up your formwork, you cast your foundation, and it stays there forever. We can do something similar, which is print in place, and that's really where we excel in what we do, because most 3D printing technologies are more like a pre-print type technology, where you're printing something that's going to go somewhere completely different. Where a lot of the innovation has happened in additive construction is the ability to print in place. But with that comes a lot of added variables. So suddenly if you're printing on the ground, we know the ground is not level. Even if it's a level slab, it's not level. And so with that, we kind of evolved different methods in order to dealing with these problems, as well as dealing with the weather. Because dealing with the weather, say it's raining, and you're trying to 3D print concrete, I mean, it just turns into mush, right? Like if you picture trying to pour a slab and it starts raining, you better cover that sucker up because it's just gonna lose its strength. And so as we go through this, a lot of these infrastructure related issues come to light, and we're working through those to make sure that by the time it hits industry, that it won't be a problem. And so with 3D construction, what you really do is you take kind of the plans for whatever you're making, whether it's a building or a bridge, and you break it out into what your different layers are. Now, this is a fairly simple type plan. We did this as a design for one of our first buildings that we didn't end up actually creating. We printed a few layers and then decided to go with another design. But you can see there that as we start from the bottom up, we have to leave gaps. So you have to leave gaps for your HVAC system. You have to leave gaps for the doors. If you have windows, you need to leave gaps for those too. And so you can break this down into as simple of a 3D model as you can by breaking these into layers. And this is what a lot of the 3D printing companies that do construction right now do. They take very few layers and then they just multiply them and print the whole building. Now, we do something a little bit different. We like to create true 3D printed objects, which means every layer could be different. And we'll get into that a little bit later. So when I talk about hype, there's a lot of companies out there creating buildings and bridges which are prone to this level of hype. Winsun is a company out of China that has 3D printed an enormous amount of buildings and other infrastructure. Now, a lot of what they say has to be taken with a grain of salt because not everything that they show is actually 3D printed. And so you kind of have to look for what the actual 3D printed components are. But overall, they've made huge strides in evolving this technology and showing to the public that you can use this technology to create everything from a mansion all the way down to single homes. But a lot of these companies, like I mentioned, end up getting stuck in the competitive stride of trying to sell their current technology based on their projected forecasts for the future. So when people say I can 3D print a building in 24 hours for $10,000, that means I think in 10 years I could probably do that. But today it's going to take a week and $100,000. But if they told you the real part of it, it's still interesting. And that's the part that I want to emphasize is while there's so much hype, there's still a lot of really good stuff happening in the field, and you just have to look down a little bit deeper. So one of the companies that has had a lot of hype associated with it is Icon. When I say 24 hours and $10,000, that comes from Icon. Their houses are beautiful. They can print their houses in just a couple weeks, and they can print them at fairly low cost, and projecting out to the future, it's even lower cost. But it's not $10,000. So when you talk about, I want to buy a 3D printed house, understand it's going to cost you as much as a regular house. Probably not more, probably the same right now. But as we project out to the future, it potentially can save the costs. But remember that a lot of people that are 3D printing houses are 3D printing the walls. Walls are one portion of that cost, and it's not the majority of the cost. And so you can only reduce the cost of the things it's actually touching. They have had some enormous success in Mexico recently. So they recently announced that they've been 3D printing a whole village in Mexico in order to house, basically transform the environment so people aren't living in slum type areas to actually having houses. And they're doing something similar in Austin, Texas, which is where they're based, by trying to produce homes for the homeless and making societies so that they can actually lift themselves up. Off on the right is a company called Apis Core, which recently had an announcement that they 3D printed this massive building off on the right. It's a beautiful building, and it's huge. It's like, I believe it's 6,500 square feet. So it's a real size building. And with that, one of the aspects they've gotten sucked into, but they've been trying to pull themselves out, is the same kind of 24-hour time frame. Now in construction, if you wanted to move into a house, does it matter if the building is built by the end of tomorrow? Probably not, because you're probably already expecting, I want to build a house. It's probably going to take 6 months to a year to get anything. And so if you can print a house in a week, that's pretty reasonable, right? Sometimes Amazon packages can take a week to show up, even when they say they're going to get here the next day. And so if you think about that in context, if we talk about construction and being able to print things in a short time frame that are just as good or close to as good as conventional, then that's really where the innovation is. And APIScore has been doing a great job of making sure all of their details are open. So they've been starting to show structural designs, how they put in the reinforcement. They've been trying to make it a more real technology. And there's other companies coming up, like S Squared, that's based out of New York, that's really, like a mom and pop type business right now. They just started up not that long ago, but they're printing garages and homes in New York as well. And so pretty much any day that you can go and look on the internet, there's probably someone getting into 3D printing construction, no matter what material it is, because this industry changes very fast. If you look at the dates on this, we're talking about APIScore went from printing that very small building, which I don't remember the square footage, it's something like 400 square foot, in 2017, all the way to printing that 6,500 square foot building, finishing it 2019. So that's 2 years, right? And so these kind of companies, they come almost out of nowhere, and then they will take over. And what we need to realize is that they're not going to take over everything, that they're going to take over where it makes sense. And right now in this kind of innovation stage that we're in, you're going to see a lot of square buildings where people are trying to create things that can be produced conventionally. But that's because it is cost effective. Now, transportation is more along the lines of bridges, roads, right? And so we're going to get into a lot of bridges. So MX3D is a company that came about in about 2014, 2015. And when we talk about hype, this one is the one that really takes the cake for me. So the picture on the bottom is a concept photo of 2 robot arms 3D printing a bridge over a canal. And they ride on the bridge as they 3D print it, going over the canal. I got this emailed to me at least 100 times over a couple weeks, telling me that people were 3D printing metal bridges. They weren't. It was a concept at that point. They had printed very small things, but the public had accepted the fact already that we've 3D printed metal bridges. These things exist. We're there. It's the future already. Well, 2019, just last year, they completed the bridge. It looks completely different. They didn't print it over a canal. They printed it in a factory type of environment. And while all of that is great, there's real innovation with that bridge. So the things that it was being sold on were the everything, the printed over a canal. The innovation there is that is a optimized bridge for structural engineers. That should get them excited, because that means everything they've always been told their whole life about what can and can't be built is changing. That now we can have actual designs which are far superior than what we use. Because we know in construction that we tend to do things the way that's the most efficient for construction, not the way that's the best for long term or for its actual use. And so they worked with Autodesk, and they are still testing this bridge in order to install it over the canal in Amsterdam. But they aren't the only bridge. There's a lot of bridges out there. This is the world's first 3D printed bridge in Madrid. That was what went around the news. The really interesting part about this is, like I said, the optimization side of it. So this was printed in panels and then installed, but all of these panels, each one is optimized. To produce that conventionally, you would have to have an independent mold for every section and then have to cast it, demold it, and everything, if you could even do that. And so when we talk about this, we're talking about where are we actually going for the future? And we're going to a future that is more optimized for architects and engineers. So architects, they're the dreamers, right? They create all these designs, and they're told, no, it's too expensive, we can never do that. Redesign it, over and over again. And then they get integrated with the structural engineers. Structural engineers say, that's not gonna work, we can't do that. And by the time you get to your end product, it looks completely different than the original vision. Now, those original visions are more real now, because we can produce things this way. This is a cementitious bridge that was installed in China. The news talks about how it's the world's largest 3D printed bridge. This was just completed last year. One thing that I don't show in the pictures is that this isn't a concrete bridge, right? Weird, right? They say it's the world's largest 3D printed bridge. Well, when you look at how they constructed it, sure looks like they put a steel bridge across that area, and then they put over this concrete cover. So can you really call it a 3D printed bridge when the majority of the structural portion of it isn't 3D printed? It's just the shell that's 3D printed. But once again, talking about the world's largest, it doesn't add any value, right? But you look at that design, that's a very beautiful design for a bridge. Producing that conventionally for that size of a gap, they'd probably tell you it's too expensive. And you can get far more complicated because these are just the prototypes, right? These are just the firsts or the seconds that these companies or these universities have done, and they can only get more elaborate from there. Here's a bridge done by Eindhoven that was a bicycle bridge, and basically each section of it was printed and then installed on site. So this was pre-printed. This one, you get what you see, right? It's actually what they talk about is actually what happened. And so these bridges, more and more, are starting to show up in the environment around us. Not just bridges actually being printed, but also the molds, tooling, formwork, you know, as well as direct printed objects. That's when we talk about formwork, we can kind of revolutionize formwork in a way because we're not talking about just wood or steel. We're suddenly talking about we can create a polymer 3D printed mold that we can put all different kinds of chambers into so that we can heat and cool it and be able to remove the things from the mold and get much more uses. So this was a mold done by the University of Maine as well as our sister lab, GSL and ERDIC. And they 3D printed this mold in order to create 76-foot-long bridge girders. They were able to reuse these molds over and over again because of this improvement on the technology. And so when you think about your applications and the problems that you have in construction or transportation, you really have to stop and think, why am I actually having this problem? Is it something that I have to live with, or is there a way we can fix it? Another kind of pre-mold, precast scenarios here is Oak Ridge National Lab does wind turbine blade molds. And so they can create much more intricate turbine blades because they can create these molds. As well as they did the exterior on the Domino building for New York. That's off there on the bottom left. And they wanted to be able to make the building look kind of like Domino sugar crystalline structure. And so they made all of these kind of window frames to have this different geometry to mimic crystal structures. And then off on the right, you can see another wind turbine blade that has a multi-material composite interior that has been 3D printed. And so with this, you can create lightweight parts that are very complex on the inside as well as the outside. And you can exploit the different characteristics of all these different materials. And so we're not as fancy, you know, we're the Army. And so what we do is we create things that are intended to be for the final structure. These structures may not be used very long. They might be used for 20 years. And so we try to create objects that can be used for what we call expeditionary type operations. And so this whole program that we're involved in was started out by being called the Automated Construction of Expeditionary Structures Program. And the idea behind that is to demonstrate and test the capability to print custom designed expeditionary structures on demand in the field using locally available materials. Doesn't matter what object. We're talking about buildings, obstacles, different culverts, and other infrastructure. And why would the Army do this, right? Seems kind of strange. Part of it is because we can save lives by doing this. If we can reduce the amount of hard labor and the amount of people that it takes to create these kind of constructions, that's less people that we're putting in harm's way, whether it's for a disaster relief type operation or whether it's infrastructure improvements in other companies or other countries. We could use this technology to across the board improve it. And so here's a little video about where we've come from and where we're going. So we started in about 2015 by building our own 3D printer. Back in 2015, you really couldn't get a large-scale printer. Like I said, right now there's probably, you can count large-scale printers on probably both your hands. So we designed this, built this in-house with our own people. And we can print objects with it about 20 foot by 40 foot by 10 foot tall. So we started out by printing a building, a small building called an entry control point, which we printed over several weeks in order to create. And then that was kind of our test structure before we got to our full-scale building. Now, remember I talked about print time. That building that we printed took 21.5 print hours. We really printed it over several months because we were building it with our own people. From there, we decided we wanted to start incorporating military personnel. So we got the Marines to join us as well as some Army personnel in order to print different objects. And so we printed some test wall samples in order to facilitate later construction, as well as we took this out to Fort Leonard Wood and we printed on site on both a foundation as well as out on the unleveled gravel to print different objects from culverts to Jersey barriers to large T-walls. We were able to use that testing in order to be able to produce the second building, which has an optimized or more optimized structural design in order to make it stronger. And we were able to print this building in 12 hours of print time, you know. But how long did it actually take us? You know, we were pretty much done with the building, the walls, in 48 hours. From there, we were able to go and very quickly do a turnaround after 2 months to go and 3D print a bridge down in Camp Pendleton. And each time we go to these places, we use the materials we can get locally in these types of environments. We're not transporting our own material everywhere we go. We use the local gravels, the local sands, and we mix it all. From there, we were able to test the bridge, and the bridge actually performed at a higher performance level than we expected, which we'll get into a little bit later. So from this, why would we 3D print infrastructure? Well, one, because it costs less. We can reduce costs for making these walls or these bridges simply because we can reduce the amount of materials you're using, you can reduce the amount of people, you can reduce the amount of hard labor and injuries, as Brandy will get into later. We can reduce the amount of construction time, which often takes the cake when it comes to costs of doing projects, because construction delays can cost an enormous amount of money, especially to the contractors and the owners. With this, we can reduce the amount of materials we're making. We can make stronger buildings. We can make stronger bridges. We can make optimized bridges. We can improve the energy performance of whatever structure we're making because we can change the interior geometry of our walls, of our bridges, and we can put in different types of reinforcement or different kinds of insulation and other materials in order to make them optimized. We can also reduce the amount of people. Now, does this mean we're going to be printing buildings with 2 people? You can, but when you print with like 2 people, it's a lot of strain on everybody in the environment. No one's going to want to do that. You're going to have a team of probably 4 people minimum in order to print these structures. And so the big thing is reduction in hard labor. So we're able to, as researchers, 3D print different things and do construction with our own people. So we are not construction workers, right? We are not used to the day in, day out grueling environment. A lot of the people that are on our team like to sit at computers all day and sit in their cubicles, you know, so getting them to pull out and get dirty is a little bit hard at times. And so when we talk about this, we're really talking about we can expand who can go into construction and how easy it can be to do. And so we've done lots of structural testing on everything from beams to our wall systems. We've done tests on different polymer systems as well as our concrete systems, and we're going to be getting into more like foams and metals in the near future. And we're really working on how do we refine the existing building codes in order to accept 3D printing construction. Like I mentioned, we printed the first 3D printed building in the Americas. With this, like I said, 21.5 print hours over several months. And with it, what we did is we printed it hollow, like formwork, with reinforcement in there. We use rebar and other reinforcements. And then we integrated it with a wood truss roof. From there, like I said, we printed wall sections. So the Marines came out, they had no training on this. They trained in 1 day in how to use this technology, and they independently operated our printer and mixed our material in order to produce 6 foot by 6 foot wall sections in 8 hours. And I mean in one business day. I'm not talking about over several weeks. A lot of the companies out there have limitations on how many layers they can do at a time, with things like 5-minute wait times or 10 or 15-minute wait times between every single quarter of an inch of their objects. For us, we don't have that delay. For this, we printed different kinds of wall structures to test for making a full-scale building. From there, like I mentioned, we went to Fort Leonard Wood. We trained soldiers. We trained the first group of soldiers that came out, and we didn't train the second. With 1 day of training, the first group of soldiers was able to train the second group of soldiers. So we're not talking about this is going to be engineers and scientists doing construction and operations over and over again. We're talking about we can have people that have never used a 3D printer or done this kind of operation and print entire objects. And with that, we were able to print everything from T-walls to down to Jersey barriers and do these on-site operations out in the rain, in the snow, in the hot weather. And we basically dealt with it all while we were in Fort Leonard Wood. We did structural testing on these wall sections in order to kind of validate the building structure we were making. We worked with Skidmore, Owings & Merrill, and we were able to do the design and wall testing for these walls in order to produce a full-scale building. And with this, we were able to test this wall, and we got 2.5 times the strength of a normal straight wall structure. Same material, same reinforcement, 2.5 times stronger with just a geometry change. Now, when you kind of think about that's like the first one, how far can you really take that as an industry to being able to optimize and increase the strength and potentially reduce the amount of material that you're using to make these kind of structures? And like I mentioned, no formwork. We're not using formwork in this at all. So there's no cost for the wood, no cost for creating the mold, no cost for demolding, no cost for the reinforcement cages, because with 3D printing, you can actually simplify reinforcement using traditional reinforcement technologies. So from there, we 3D printed this building, and the reason we did it is we were testing the 48-hour or the 24-hour hypothesis that has been in the industry. And so we pushed hard, and we trained Marines on how to operate this, and their first training was printing this building. They didn't have any prior training in 3D printing. And so they got very excited about 3D printing, and so they didn't want to do shifts, which meant we actually went home and took a break. So when I say that we printed this building in about 48 hours, that includes time for them to go home 12 hours, go back to the hotel, sleep. Print time, like I mentioned, is 14 hours for print time for this whole building. And so when we talk about those kind of numbers, 48 hours for printing the walls is feasible. And so with this, we're able to really expand our technology and go somewhere. And like I mentioned, we don't have to operate independently. So we can operate with conventional construction. We can use reinforcement and anchoring strategies similar to everything else. With this, we printed the first 3D printed bridge in Camp Pendleton, like I mentioned. The reason why this is important is because with bridging assets, there aren't a lot of them in the military, and so we're able to take these and use them for either forward or behind operations. We are able to print and place this in 6 days. That's 6 real days using the materials down at Camp Pendleton. And when we tested this bridge, we printed the first 3D printed bridge, and then we brought it home and broke it. So you can't go visit the first 3D printed bridge, sorry, because we broke it. We brought it home and we tested it, and it was 2 to 3 times the expected strength of what we wanted. And so we printed this as a pedestrian bridge, and by the end of it, this 32-foot long bridge was able to essentially support vehicles going across it. And so as we move towards the future, it becomes more of how do we 3D print vehicle bridges? From here, we scaled up and we increased our output. So how do we use 3D printers with traditional concrete trucks. Concrete trucks hold a lot of concrete, and if you don't use it fast enough, it cures in the truck. And so what we did is we increased the output, and we were able to produce a structure in one day, essentially, and be able to print the foundation, the roof, and the walls of it with that larger bead size. And so with this, I'm going to hand it over to Brandy, but as we move on, we're talking about everything from the codes and standards all the way to the construction types and really evolving this as a technology. Brandy? Brandy?
So I know it's 12, so I'll quickly go over these slides because I'm a little hungry as well. And as you can tell, we are very passionate about 3D printing. We could talk about this all day. My nerves got to me at the beginning, but I love this stuff, so I will quickly go over these slides with you guys. Wanted to show you these types of printers. These are some of the types of printers that are used in typical concrete construction that we do at our lab. But the gantry style and the articulated robotic arm are ones that are used in the transportation industry right now. 3D printing did start in 1980. It has since evolved. So the crane and the jib style, those are the ones that are being used currently. What I wanted to talk to you guys about is that there are some standards that are being used right now, but there is a disconnect between actually printing, 3D printing, and the type of printer that you are using. So since there are different types of printers, the standards for each printer is different, which means that the safety and the codes that you need for those printers and the printing process will be different for each one, so you can't just write something that's standard to go across the board. The ASTM, the American Society for Testing and Materials, they do have certain codes and standards that apply across the board, like the guidelines, specifications, and terminology, but it cannot be applied to everything. And I say that because we do work on construction sites. Typically, or technically, anywhere that work is being done on a site is a construction site, whether it's in any type of industry, construction, or transportation. So these are some of the common hazards that are on construction sites. We normally see something like caught between mobile equipment, scaffolds, ladders, things like that. Sharp objects, those are found everywhere on different types of construction sites. So where you see those hazards, there are rooms for error for accidents. The accidents are what causes downfalls in some of the 3D printing aspects for the trough of disillusionment pit that some companies fall into because they don't have their safety standards into play whenever they have the 3D printing in their companies. So if it's not safe, then you can't continue with the 3D printing process for your company, therefore it will fail. The printer does not care if a human is standing in the way, it will continue to print because it is a machine. It doesn't care if your fingers are in the way, it doesn't care if your hair is in the way, it doesn't care if you hopped over a beam and tore your calf. It will continue to run. This guy was okay, this is her husband. He's okay. I got this picture through a text message and I'm like, what is going on at work right now? His hard hat just fell off and someone ran over it with a forklift. But these things can happen, so it's very imperative that even if you want to have 3D printing in the transportation or your company, that you incorporate some type of safety and assessment risk in your project management plan, because if you do not, it will fail. So some of the simple methods that we use at Searle, or where we do our construction, whether it's at Searle or at Camp Pendleton, we take in consideration an activity hazard analysis. And what that does is that it goes through every step, kind of pre-planning every task that will be associated with 3D printing. It assesses the risks that are associated with the 3D printing process. It writes it down, whether you need proper PPE, do you need steel toes, do you need eyeglasses, what the environment's going to be. It writes it down. You give that to everyone that is going to be associated with the 3D printing process. After you write it down, you give it to all the associates. They sign it. You give it to a safety coordinator, and you file it away. That way, if anyone gets hurt, they knew what the risks were. That's me. This is also a way to safeguard yourself as well. If you go through the printing process one time. The next time that you do it, the next iteration that you do print 3D printing for your company, then you know, hey, last time it was very hot. We may need to have water because we didn't have water last time. Or the next time we print, we probably should have this roadway clear because there's going to be some forklifts that's coming this way. Or the next time we print, we probably shouldn't print 17 hours straight. So these are some things that you probably should take in consideration because there are safety measures. And safety is the health of your employees, as the health of yourself, and it just shows that you actually do care, because you do. So in order for 3D printing to be successful, another aspect is that we continue the research and continue testing. Because when you continue research and testing, then the 3D printing process will only become stronger and innovative. The reason that you test is that you see what the 3D printing process will do with a material, with a component, and you can only build from there. And that is where the innovation comes from. That's where the next iteration comes from. So if you do anything with a prototype and you want to scale up, well, think of the scaling up with the 3D printing process as well, because there are large scale and small scale and large scale. So key improvement areas, like I said before, and Megan had touched on also, will be in your reinforcement structural abilities. Also the automation process along with robotics. We talked about automation, well, there was a lot of speaking about automation processes with the automotive industry and trains and things like that. The cost, it's still pretty high for the acquisition of 3D printing in a large scale. But in the years to come, it will dwindle down because we want to regulate the industry with large-scale 3D printing as with small-scale 3D printing. Thermal analysis, energy analysis, material compositions, because there are so many different printers doing so many different things, you can print with a lot of different materials, whether it be something of the bio nature or just a cementitious material. So for the present, right now, we do have 3D printed structures. At the top, she did speak about Ollie and the Honda Vibba monkey motorcycle, which actually has a 3D printed brake line. I'm a little iffy about that, but just because I drive a motorcycle as well, and I don't want to trust, yeah. And then we also have the Angel Train in 2019 implemented the tray tables, armrest, and the headrest for their trains just because it is a part that they are continuously replacing. So they said, why don't we just print it? So that company is saving a lot of money there. So in the future, we are seeing that smaller nozzles are printing larger objects. As you can see, the tire with the rim at the top corner there. GE Transportation wants to incorporate 250 new objects or components into their trailways by 2025. And we also have the SRC that would like to start using drones to deposit asphalt for the construction, to resurface constructions using a 3D printer. So that would be interesting to see a drone go right in front of you to deposit asphalt into a 3D printer that will resurface a pothole as you wait in traffic. So it's going to take me a while to go through the rest of these slides. So if you want to, no, it's okay. I know, I understand. So like I said, it's a rabbit hole that we could talk about all day, and we really appreciate you allowing us to have this time to come and speak to you today.
Can we give our speakers a round of applause? Clearly, it's a really big topic. Thank you so much. Lunch is now. The summit will reconvene at 1:30. Make sure if you haven't gone to see the Cassie and take a ride in it downstairs, it will not be available after 1:30. Thank you so much.